Hey guys, Mr. Mackey here. Now yesterday I showed you a brand new method on how to find percentages of amounts, to find the original amount when you have the new amount and the percentage when you have the original and the new. And I set you two questions for this problem. I started off with £90, an object was £90 and it went up in value by 20%. How much was the new value? So, if we're adding 20% on, then it's going to be 120% in total. And remember what we have to do? Firstly, we need to convert that percentage into a decimal, which is 1.2, and you multiply that by the original, and that will get us the new value, which is £108. Sorted. Now, I want to find out what percentage of that new value is £36. So what's the percentage of that? So let me just make some space and we'll show you. So we know that £108 times the decimal version of this unknown percentage equals £36. So how do we find that unknown percentage? Well, we're going to have to rewrite the problem. So to find the unknown decimal, we do 36 divided by 108. And when you do that, you will get 0.333333333333333333 recurring. It goes on forever. I couldn't be bothered to say them all. It would be a long video. It's also known as a third. Funny enough. So, because I don't want to write all those threes, I'm going to do it to two decimal places. So that would be 0.33. Now, let's convert this into a percentage. So if we divide by 100 to turn the percentage to a decimal, you have to multiply by 100 to turn the decimal back into a percentage. So you times it by 100. So the actual percentage is 33%. To the nearest whole, because obviously that was to two decimal places. Fantastic work if you got that. This is the last day we're going to be doing on percentages for now, and we're going to be doing something I've not done before and was requested by someone. I cannot wait to go over this. Let's do compound interest. So compound interest means when an item decreases or increases in value by the same percentage every time. Let me give you an example. I bought a car that was £5,000. I know, what a bargain. Now, every year after I bought that car, the price will drop by 5%. How much will the car be worth after 7 years? Okay? Now, there's two ways you can do this. The long way. Now, what we first need to do is we need to turn that into a decimal that we need to multiply by. So, if it starts off with 100%, we're taking away 5%, that becomes 95%. That turned into a decimal becomes 0.95. Sorted. Now obviously, there's two methods we do this. We find 95% of 5,000, then we do it for the next year, and then the next year, and then the next year, and then the next year, and it'll take way too long, and this will be a long video, and I might even fall asleep by the end of it. But there's a quicker way. So, we're still doing 5,000 times 0.95, but that 0.95 is going to be to the power of how many years we're doing. Because it's 7 years, it's 0.95 to the power of 7. Because what it's basically doing is because it's happening 7 different times. That makes sense? So, what you enter into your calculator, because you will need a calculator for this, 5,000 times, you need to put it in the brackets, because if you don't put it in the brackets, it might do it to the whole problem. Remember what BidMaths taught us. bracket 0.95 and then to the power of 7. Now obviously because this is in pounds, we have to do it to 2 decimal places. So the price of the car after 7 years will be £3,491 and 69 pence. And that's how we can use compound interest. It's a simple trick once you know how to do it. Another big example where compound interest is important is if you put money in a bank. I put £164 in the bank with 12% interest. Like that will ever happen. And I want to know how much money will be in my bank in 12 years' time. A lot of 12s there. So, first step is we need to find out what the actual percentage is. So if you start with 100% and we're having 12% interest, so that's going to be put on top. The actual percentage is 112%. So now let's turn that into a decimal. So that turned into a decimal would be 1.12. And now we're multiplying that 1.12 by 164, but it will be to the power of 12 because there's 12 years. So we enter that in our calculators, 164 times 1.12 in brackets to the power of 12, and you will get to 2 decimal places, £638 and 94 pence. And that's all you have to do in problems like this. It's really simple when you think about it. Now this is the final sort of question you'll get for compound interest. I invested £150,000 into a company. Clearly I must have a lot of faith in that company. The moment that money was put into the company, which I did it in the year 2000, I got 5% interest. So the exact moment the money went into my account. I now checked that account in the year 2020 because there's a lockdown and I have nothing better to do. How much is now in that account? Now, the most important thing is we need to find out how many years it is. Now for this, we're including the year that we put the money in. So that actually covers 21 years. So now we convert that and we find out the percentage of that. So if it's 100%, adding the 5% interest, that is 105%. We turn that into a decimal, 1.05. We're still timesing it by 150,000. And we do it to the power of 21 because it's 21 years. Enter that into your calculator. And you will get to 2 decimal places, remember, with the pound sign, when I can write pound signs properly, 417,894 pounds and 39 pence. And that's how it works. It's so cool when you think about it. I bought a car. I can't remember how much I bought it for. 11 years pass. And for each year, the value of that car goes down by 8%. I sold the car for £3,500. What was the original price of my car? To 2 decimal places, because obviously pounds. Quite a challenge, isn't it? And that's because this is your challenge for today. I want you to find out what the original value of my car was. You have the number of years, you have the percentage, you have the new value. All you have to do is reverse the process. What do you think you have to do when reversing it? How do you do it? those are all questions that I think you'll need to figure out this problem. Tomorrow we're doing a one-off special lesson on negative numbers, because a lot of people have wondered what on earth are negative numbers, how do we use them, how do we work with them. So we'll be doing a one-off lesson on that, and then for the other 3 lessons of the week we'll be looking at factors, highest common factors, lowest common multiples. What are they? We'll see. Good luck with this problem and have a good evening, guys.